Today we'll be talking about the number of ways you can select k objects from n distinguishable objects with replacement in order does not matter. To go over what exactly we'll be sampling, there will be a collection of objects, there will be n of them, they will be distinguishable, and we will select k of them. And the order of our final selection does not matter. In addition, whenever we select an object, we're going to put it back into the selection pool so we can choose it again. It won't go away. The reason why this is tricky is because of those two details. That order does not matter and that we're selecting with replacement. Because order does not matter, we don't want to overcount for cases that are the same samples, just ordered differently. And because we're selecting with replacement, we don't want to get rid of an option after we've selected it. We want to keep it in there for us to be able to select in the future, which is tricky because it's often the norm for other problems, such as permutations, where order does matter, and where you select without replacement. The short answer is that the number of ways we can do this is n minus 1 plus k, choose n minus 1, or n minus 1 plus k, choose k. To go into more depth as to how we achieve this answer, let's look at how we can visualize this problem in a different way that's more intuitive to counting. We can visualize each of the n objects in the pool as a bin, and we can visualize k balls, one for each selection we're allowed to make. So the selection of one of the objects is equivalent to placing a ball into a particular bin we have. The reason why you can use balls in bins is because the situations line up in certain details. For instance, there are n bins representing the fact that we have n options to select from. We get to allot k balls representing the fact that we make k selections. The bins are distinguishable and they're not ordered just like we want. And the bins do not go away after a ball is placed into them, representing the fact that we are selecting with replacement. So if you put a ball into a bin, you can put another ball into that bin, which is what we want because when we're selecting with replacement, we want to be able to select one option multiple times. We can represent the bins with delimiting characters in a string of characters, as we have here. And the bins are the spaces that lay in between or outside of the delimiting characters. And that is where the balls can go. The number of ways we can allocate the balls amongst the bins is thus equal to the number of ways we can permute this string. This particular string contains 4 delimiter characters and 7 ball characters, meaning that there are 11 characters total. So if we're looking at permuting the string is equivalent to assigning any 4 characters of the string to be delimiters and leaving the other 7 to be balls, or assigning any 7 to be balls and leaving the other 4 to be delimiters. These two options are equivalent to choosing 4 elements from 11 distinguishable elements without replacement and without order and mattering. Or the other option was choosing 7 elements from 11 distinguishable elements without replacement and without order mattering, which are 11 choose 4 and 11 choose 7. If we want to generalize, this is n minus 1 plus k, choose n minus 1, or n minus 1 plus k, choose k, which is the result we got before. And the reason why this is the more generalized solution is because if we look back here, we have 11 on the top and then 4 or 7 on the bottom. And this is because we had 11 characters and we had to choose 4 spots, or 11 characters and we had to choose 7 spots. The reason why we had 11 characters is because we had to have the number of choices there were -1, that many delimiters, and then the number of selections we got to make, k, that many balls. So the generalized solution is this way, because the string will have n minus 1 delimiters and k balls, and you're either choosing which spots will be delimiters or which spots will be balls. So you have a total of n minus 1 delimiters and k balls for a total of n minus 1 plus k characters in the string, and you're choosing n minus 1 characters in the string to be delimiters, or you're choosing k characters in the string to be balls. So this is why the number of ways you can select k from n objects with replacement, with distinguishability, and without order mattering is n minus 1 plus k, choose n minus 1, or n minus 1 plus k, choose k.